One thing fascinating about our weather, all kinds of things are created. By things, I mean different features, different patterns. Now in this graphic, we can see the global broad-scale wind patterns in general. Of interest is a zone called the ITCZ, the Intertropical Convergence Zone. It's usually down along the equator, sometimes south, sometimes north. It kind of flops around. In the atmosphere above that zone, approximately 20 miles above sea level, is a band of winds, first blowing from the west. Then they turn, they blow from the east, and they go from the west, then from the east. What is fascinating is the fact that this band of winds changes directions every 28 to 29 months. Another oscillation, another cycle. Details are sketchy on any teleconnections to the Southern Oscillation, El Nino, but most likely both features affect each other. Now let's take a look at this graphic. The blue indicates winds blowing from the west. Then we have the winds blowing from the east, the red. And this is just a time series here that it lasts, 28, 29 months, then it changes. So if you can see up there, 20 miles above the surface, those winds are just changing. Then they're west and then they're east. And a fairly regular frequency. Fascinating things going on. Now this graphic is powerful. It tells a lot of the story. You're looking north, you're right near the equator. Asia and such would be on your left, North and South America would be on your right. And we're looking at the Pacific Ocean vertical profile, plus we're looking at a vertical profile of the atmosphere. Now, we see MJO, Madden-Julian Oscillation. Now this thing happens a lot, all right? So let's say it passes by where you are right now, this wave that moves through the atmosphere. It'll be back in 30 to 60 days. It's fascinating stuff. So you got the MJO, it's involved in this. And then we see down at the bottom there, it says Kelvin wave. A Kelvin wave is like an ocean wave, but it's beneath the surface and right on the surface. And in this case, it's moving from the west to the east. El Nino starts to the left of where you see Kelvin wave, close to Indonesia, Southeast Asia. Usually the surface winds, lower level winds, are blowing from the right to the left. That would be from the east to the west. But as the El Nino develops out to the west there in the western Pacific, the wind will eventually shift and start blowing these strong winds from the west to the east. The Kelvin wave helps to move El Nino eastward. And with that, you have very warm water, you have increased convection, there's a lot more moisture going into the air, a lot more energy going into the air, a lot more thunderstorms going in the air. You're changing the temperature pattern, the pressure pattern. It's really fascinating. Rossby wave, we'll cover that in just a moment, but the Rossby wave is involved also. And we can see why it doesn't rain. If you look where the L is and the movement, the arrow moving to the right, you see the curved arrow down, that's air going down. It's not going to rain in there. But where El Nino is, there's air going up, lots of energy going up, rain, thunderstorms, all those things. And this system, where you see the L, the low pressure area, progresses across the Central Pacific, across Nino 3.4, all the way to South America, where it weakens very rapidly. But a fascinating presentation. It really covers a lot. Now, as the El Nino system moves across, the Rossby wave and the Kelvin wave, all those things are moving to the east. Precipitation goes with it. And in behind it, you see the dark area right in here, that's lack of precipitation. The system has moved over to the east, that's where the rain is, that's where, in this particular graphic, El Nino has gone, and in behind it, downward motion, no precipitation. Really fascinating part of our weather, and it affects the weather around the world. Now we're looking at a series of troughs of low pressure and ridges of high pressure, moving from west to east across the globe. And really it's a Rossby wave is what they're called. And we're looking at about 18,000 feet above sea level. These systems are, as I mentioned, called Rossby waves, and they can become quite intertwined with an El Nino event. The weather can be stormy near the bottom of the trough, on up to the northeast a bit, and then about halfway to the top of the trough, to that hump in the ridge, weather's good. And then fair weather can be expected from the top of the ridge to about halfway down the next trough. So it's a series of storms and a series of good weather teleconnected to El Nino. Now we quickly jump back to a previous graph, that vertical cross-section of the ocean and the atmosphere, and just to the west of the L, there's a red dashed line. There it is. That dashed line represents the center line of a trough of low pressure in the upper atmosphere, and once again, that's a Rossby wave, so it's all connected, folks.